So we're going to be talking about SRE, DevOps, and platform engineering today. My name's Chris Ayers. I'm a senior customer engineer at Microsoft. I work on what's called the Fast Track for Azure team. That's actually part of Azure engineering. So I work closely with the product groups. I help customers build and deploy stuff on the Azure. I've helped write demos and samples. I've helped contribute to the well-architected framework and like service guides. Working on all sorts of interesting things. You can find me on all the socials, and all the stuff you're hearing today is just me talking about my opinions. So has nothing to do with where I work. We're going to talk about some common problems. We're going to go have a little bit of a history lesson and some jokes about that. We'll talk about what SRE is and some of the technologies behind it and ideas and concepts. And there is, as you can tell from the diagram, there is overlap. So a lot of stuff we talk about with SRE might apply to DevOps, might apply to platform engineering, but you know, I run DevOps Days Tampa Bay. One of my co-organizers, he is the head of SRE at a major financial company, and another person is the head of platform engineering at a major consultancy firm. So we talk about this stuff a lot. And so again, these are just my opinions. If you agree or disagree, hey, chime in. Like, I want to have a conversation about it. So historically, there's been this divide. Anybody who really kind of identifies more dev than ops? Anybody that identifies more ops as dev? Us and them, a little bit, time to time. Maybe there's some silos, maybe separate realms. Like you got different priorities and different responsibilities and goals. And so it sets up some animosity from time to time. So where we might have this like focus on writing code as a developer, it's more about managing the infrastructure and the deployment and the service reliability as an operations person. And sometimes those things go against each other. You know, making sure our code works, but then making sure that we can handle changes in configuration and infrastructure. Let's get those features out. Let's make sure it runs, right? Like caution. So we have to worry about uptime and patching, but I also need to worry about code quality. So we have two different areas of focus, and this has been a historical problem for a long time. You know, we had this wall of confusion. Who's had things thrown over the wall at them? Who's thrown things over the wall at the other people? Yeah, because you're so focused on your work and your team. And this is really what led to some of these ideas. You know, we've had slow releases, missed deadlines, all the finger pointing and blame games. Who's lived this? Because I've lived this. And in the earlier years, we started realizing that this was a problem. We started realizing that we needed to bridge the gap between these silos and start breaking stuff down. One of the first things that popped up was the SRE book, Introduction to SRE. This came out of Google, you know. And the guy who came up with the idea says SRE is what happens when you ask a software engineer to design an operations team. When I argue with my platform engineering friend and my SRE friend, I say SRE really has a developer background more than it has an operations background. I think code is involved in the day-to-day and what you do, more than DevOps. A lot of responsibilities fall into that reliability aspect, like availability, latency, performance, efficiency. Sometimes understanding change management or monitoring or emergency response, even capacity planning. Like they have input a lot of times into, are we going to keep working on new features or do we need to get rid of some toil and some maintenance issues? And we're going to talk about these concepts as we go. But, you know, I hear you like systems, so I put systems engineering in your engineering system so that you can engineer your systems while your systems are engineered. Like site reliability engineering, this is what we got. Like it is a very different thought process. It's not just, hey, I'm writing code. Like if you're doing it right, if you're really diving into SRE, you're gonna start seeing a lot of things. Hope is not a strategy. We're gonna measure things, we're gonna predict things, and we're gonna understand what's happening. The one SRE guy up here is like, yeah. All right, so SRE is about embracing risk. No system is perfect. You have to understand that high reliability is tough, that unexpected failures are going to happen, that you're gonna have a shortcoming and that you need to proactively address risks. So this is like understanding that there's a problem coming with your system and being able to manage that. I mean, the risk I took was calculated, but man, am I bad at math. I mean, I had to put this in there. I love this one. It's so good. All right, so, everybody knows about 2 nines, 3 nines. Like, we're just adding some 9s and some 5s. It can't be that bad. We go from 48 minutes down a month to 26 seconds. I didn't go into this, but like, really over the course of a year, going from 8 hours down to 5 minutes down, trying to get more 9s is an exponential growth. Exponentially more expensive every time. You need to understand things like composite SLAs, because one service might have 3 nines, one service might have 4 nines. You need to understand that if you're depending on unreliable hardware or unreliable services, that you can't expect to have a perfect system. We just have to acknowledge that it's not possible. So how do you mitigate the risk and how do you respond to it? And that's really where this focus in SRE comes from. You are gonna have some of this focus in DevOps and platform, but this is like where some of that mindset really starts. So you're gonna see these terms pop up all the time. SLO, service level objectives. SLI, service level indicators, and SLAs. So we start with SLIs. This is just like a metric. Error rate, response time, throughput. Then you build that into a time frame, an objective. I want 99% uptime every month. So it's an average over a time period. SLAs are the ones where that's what you give your customers. That is a legally contractable thing. That's the thing you've agreed to. It's formalized. So let's kind of start with SLIs. Again, they're the basis of everything, and then you build SLOs and other things on top of them. So we've got monitoring, we've got observability so that we can understand the metrics. These all feed into an idea of an error budget. So we've assumed we're gonna have risk. We've assumed that no system is perfect. So we calculate how much downtime and error we can tolerate, okay? That's where our error budget comes from. I mentioned we can have 8 hours of downtime at like 2 or 3 nines. That's our error budget potentially, a month. But maybe we don't wanna go up to the maximum of our error budget. Maybe we wanna determine a number. Well, I mean, you really can't go over your budget if you don't have one, and most people don't have one. So let's build one, okay? We take our number, we want a success rate of like 99.95, 3.5 nines. That's what we want as our objective. We're gonna measure it of failed events, or 95th percentile over under 100 milliseconds over 5 minutes. We're gonna have a time frame, maybe over 28 days. The last month, I want 95th percentile latency. And this is how you calculate this stuff. Like I said, it's not just a gut feeling. It's not just, hey, the system's been pretty good lately. It's like, no. We're gonna calculate this. 1 minus our objective is our error budget. So we got, 9995. Our error budget's that. So over 28 days, we can take our error budget, times it by the month, by the hour, and we can calculate. We have 20 minutes where we can be over 95th percent latency of over 100 milliseconds. So we calculate this out. It's intentional. Like I said, it's managing and understanding risk. So what happens when we run out? Hey, the system's been down for 20 minutes or is screwing up. What do? Maybe we stop making new features. Maybe we stop doing changes or feature flags or experiments. Maybe we now prioritize reliability. We've hit our budget, it's a problem. We need to be more reliable. Bug fixes, we gotta minimize toil. So toil we're gonna talk about, but manual tasks. Maybe we missed a monitoring signal, we need to look at our monitoring, or we need to improve our automation, or we need to do better testing. So the focus of development and operations has shifted towards that reliability because we've made the system more unstable, and we need to get it back to more stability. We need to improve reliability. That site reliability engineering. Like we're doing engineering work. We got to improve reliability. So I mentioned toil. Toil is manual work. You need to do stuff. SREs and DevOps and platform use automation to help minimize that toil. Who's seen this wonderful comic before? Yeah. We really do want this top one. We want to avoid the bottom one. So toil would be, who's had to just restart a service when it fails? Yeah, super productive, right? Manually scaling it up or down when you could have an automated system do that. Restart, running and doing a maintenance task in a database. Making reports from text files and logs, oh yay. Who's had to clean up temp files before? These are toil. Could you automate it? Probably. Might it take you a little bit to do it? Would it probably save you some time when you're done? Yeah. What happens if you forget? Would something go down? Go on vacation, you forget to clear out the temp files and the system goes down, maybe it makes it important to automate that. So managing toil, notice this is where we're understanding what's happening. So when all those little tasks add up and it's taking you from focus and monitoring, it's taking you from doing actual work, you know, and you have no capacity to do things better. You can't make the business better. You can't even reduce toil. This is where you get stuck. So understanding that as soon as the toil starts to go up, you need to do things to reduce that. Again, you see toil as more of an SRE term. I didn't hear it a lot when I was in DevOps only, or platform. It's a different way of thinking if you're not used to it. Who's heard the term a lot prior to this? A couple of the SRE people. Good concept to take back? All right, feedback loops. You're gonna see these everywhere. You're gonna see these in DevOps, you're gonna see these in platform, feedback loops. We want to measure things, and we want to take the learnings and improve the system. We want to do this in development, we want to do this in operations, we want to do this in monitoring. You don't just throw a system out into the cloud or on a server and not look at it. You gotta monitor it. You gotta identify areas of improvement. You can adjust your strategies, like, hey, how you're deploying, how you're building, how you're writing things. It also lets you communicate better. You know, that leads to monitoring. Who has a distributed system running on more than one server or more than one service? How easy is it to track down an incoming request and it goes to bing, 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 bing? Do you have a good distributed tracing system? Observability, open telemetry? These are important. As soon as you go distributed, it is so much harder. You need correlation IDs, you need all sorts of stuff, and understanding that, you know, those systems like OpenTelemetry and centralized monitoring can help you put the picture together. Makes it so much easier to figure out that an anomaly in system A is going to take down system B because you have a dependency. It gives you true insights into system health. So, you know, we have the idea of both white box and black box monitoring. So when we say black box, we're just talking about what the system produces. Here's an output. Here's a log. You know, it gives you some pain in trying to understand what's actually happening. So that's where white box comes in. Like, I can look inside, I can see the internals. So not just, you know, CPU and memory, maybe I have that distributed trace and open telemetry tree where I can see this call kicked off this other call. It's taking a certain amount of time. You know, I can look at those component interactions or those metrics. I can get debugging stuff. You gotta use both. So as SRE, they might actually be in the code improving these white box monitoring capabilities. But as operations, you might be more used to these. Like, do you have a ping test, or is it available? So each gives you a picture, but one gives you a more complete picture. You know, another topic that comes up when you're monitoring, and this comes from the State of DevOps report, this comes, like, SRE loves these. Who's familiar with, like mean time to failure, mean time between failure? Yeah, go read the State of DevOps report. So, mean time before failure, this is how reliable your system is kind of overall. Like, how often do failures happen? Are they happening all the time, every once in a while? Mean time to recovery or repair, how long does it take you to fix? So if the server's under your desk and it dies, do you gotta go down to the store and buy a new one or wait for one to be shipped and then reload it and reinstall it? And your downtime might be days or weeks. If you're in the cloud and you're using infrastructure as code, you might be able to click a button and have a new system up in minutes. If you have highly available and reliable with failover, it might just be bloop and no downtime. So those are really important aspects. Notice the bottom one, mean time to acknowledge. Are you figuring it out, or are your customers figuring out that there's a problem? Who's been told that your site is down by a customer before? I have. It doesn't feel good. And your managers and your bosses and the owners don't want to hear that. So you got to set up the monitoring. You got to set up the alerting. You have to instrument your system in such a way that you're aware of what's happening. Did your orders per second go down to 0? That's weird. Wonder why that is. Maybe we should alert on that. So, is everything okay, or is just monitoring broken? Who gets suspicious if their email gets too quiet? There's no more alerts or status things coming in. Just nice and quiet, or is maybe something broken? So you need to be aware of that. You also want to be aware of things like not just your at error budget or something broke. Maybe you're just getting near it. Like you're getting near the edge of the dam. Maybe we shouldn't wait till it collapses. Maybe we should kind of go try to fix it before it gets too bad. Like you don't want to have too much noise. You want to have actionable alerts that mean something. If just memory is high, cool. What do you do about that? If it's memory is high, we need to restart the service, that's an actionable alert. So understand that just alerting on a high number doesn't tell you anything. Alerting on a high number that you can do something about and then automating that even is better. You want to be very clear. Like I said, when you're doing distributed systems, you got to have good metrics. You want to have consistent metrics across your components. You want to have really good monitoring at the system level, at the component level, so that you can understand things. And when stuff goes down, you want to have postmortems. You want to understand your root cause analysis. And you want to look back at your monitoring. So we had an outage at 1 p.m. What happened at 12 p.m.? What happened at 12:30? Did we get an indication that system A was about to go down from the metrics, the logs? And if not, what do we need to add to capture that? And if it was there, why weren't we alerting on it? Visualization is a good way, but visualization might not always be ideal. Like you need to understand what you're looking at. Just seeing numbers go up and down might not give you enough context. Yeah?
Circling back to the postmortem, do you have an argument? Because I'm a big fan of postmortem, I do that.
Yeah.
My colleagues or supervisors, they don't really believe in that. And I kind of ran out of argument.
Yeah. I actually have a slide on that in a minute. So why don't we circle back on that in just a moment? Yeah. So just regular reviews and things. Alerting. Make sure you have priorities. Make sure it's clear. Like I said, don't have alert fatigue, and ensure it's only relevant. If you have on-call engineers, who's an on-call engineer? Who does on-call? See, I only see a couple of hands. SREs are probably on call more than DevOps or platform because they are more involved in keeping the reliability up. And it's a concept that not everyone thinks about. Very common SRE thing is you build it, you run it. Like they handle some ops, they handle monitoring, they handle alerting. So you have to rotate, you have to have good handoffs, and you have to make sure you don't have burnout and clear documentation, clear tools. Having like Jupyter notebooks where you can like run the commands, having executable scripts, all super easy stuff to implement. Have a systematic approach. I have issues where I have to communicate to other teams. So you have to have clear channels of communication and be able to roll back things. So push button deployments, infrastructure as code. this really leads to incident management. And you're going to see a lot of incident management with SRE, more than the other disciplines. So having a response team, having somebody in charge, having a call log and a documentation, and then that leads to that blameless postmortem, like understanding after an incident what happened and what led up to it. Now, the key word I put there, blameless. You know, after a plane crash, they don't just go and take the pilot and go, oh. They try to understand everything that happened that led up to it. If you make people afraid to talk about failures, if you make people afraid to talk about incidents like security breaches, then they won't report it. Then it goes on more and more, and you can't improve the system. You can't prevent incidents in the future.
Can the postmortem be blameless if it's tied to your bonus? I tried explaining my CIO this, he wouldn't get it.
Yeah, it's a big problem because, so if you have set up a system where people have too much access and they can make an easy mistake, if you have systems where clear procedures aren't documented, the events aren't monitored, and there's problems with timelines, and the failure is of the system, not the human. Like if it's a human error thing, why was the human in that position to make that error? If you could have oversight, somebody else doing eyes at it. You know, you have to do a break glass in order to make the change. Oh, we don't do the manual change. We check it in, it has peer reviewed, someone approved it. Like we have processes in place. And okay, somebody missed something. Cool, can we add in additional security checks? Can we do DAST and SAS scanning? You know, every time it's not really blame the person, it's what is wrong with the system that maybe, you know, there was an event or an action that we did. Maybe we had a miscommunication and we should formalize that. You know, it's not the person. You know, if we aren't supporting them and we don't have the tools and systems in place to make it effective, it's really the fault of everybody. And that's why you shouldn't tie those type of incidents to the bonuses. If they covered it up, if they lied, that's a different problem. But if everyone's open and honest and has positive intent trying to solve the issue, that's where you succeed.
I agree with what you said. I think a core underlying prereq to all of this, or making this successful, is a culture of trust.
Yes, a culture of trust and transparency.
So intangible that people try to hide those things, hide that trust, the pain of building the trust behind all the metrics and the tools and the implementation.
Yes.
But it's easy to point finger on a red number versus identifying why there is no freaking trust.
And I'd talk about that a little bit more. Usually, you're going to see culture come up more with DevOps than with SRE. That's why there's a big overlap here. But like this is just psychological safety. If you look at like State of DevOps report, if you look at pretty much anything around developer velocity, satisfaction at your workplace, all of them have, I'm psychologically safe, I can communicate, I can speak my mind, I can share that there's a problem with the system. We you know, they prioritize like work-life balance and preventing burnout. Sometimes it's just not a good place to work. People leave managers and jobs for a lot less than not trust. But it's important to have, the sequence of events, what was affected, what happened, how it happened. But it takes trust, like asking those questions. There was one company I worked at where devs had access to QA, and we would release, and sometimes things would break. One guy would go out in the QA and fix it. Go on vacation, we go to prod, things break. Because he didn't communicate that he missed something and that we needed to redeploy and check it in, he just fixed it in QA. So having permissions to like not allow that change to happen and limit access, that solved that problem in the future. But you know, it's covering things up is the problem. You gotta be open and communicate. But this all ties back to release engineering. So how do you do version updates? How do you do release? How do you do rollout strategies? How do you put some of these things in place to prevent the human element, that's there sometimes. Like, hey, I right-click deployed, I edited the file on the server, I did the thing. There's a ton of different capabilities that come with SRE and DevOps and platform that all touch on different types of releasing. There's a lot of strategies for zero downtime deployment. There's a lot of strategies for rolling forward and rolling back. Most of it involves trying to limit the blast radius of change. This is a term you're going to hear in DevOps, you're going to hear in SRE. I always tell people, release early and often. You want to release as much as possible. The State of DevOps report was telling stories around, one of the metrics they measure is number of releases per developer per day, which scares some organizations. I've worked at organizations and I've helped them with their DevOps transformations. And what happens is they do their deployment and they're releasing and they break dev. And they're like, whoa, whoa, whoa. We shouldn't release so often. We should release once a sprint. So they start releasing once a sprint, and now the changes go from a couple of files to hundreds of files and hundreds of changes. And so now they're doing this release once a sprint, and they start breaking more things because they're not deploying as often, and they're deploying more and more stuff. So now we got to do a hardening sprint. So now we're going to release every other sprint because we got to QA it more, right? Oh, well, now we're breaking more things with databases. Now we should release once a quarter. We should put a cab in place to make sure we understand the changes. Let's release once a year or twice a year. Anyone had that happen where they are? How effective is it? Does it work well? Not at all. Not at all. So the more often you release, the smaller that blast radius of change. And then you can do more things. Internal testing, canary testing. You can leverage feature flags. I'm a big fan of feature flags, but it does require some maturity with code. It means, we're putting potentially unfinished code into production, but we're not exposing the endpoints, or we're not turning it on. We've got it turned off, but it's checked in. We're scanning it, but we can turn on and turn off features per user, per group, per environment. Like I said, it makes pushing bits onto a server, which is what deployment is, and turning them on and off into two different problems. We get really good at pushing bits. Turning on and off features is a release thing. It's a business thing. Like, what's the real difference between version 1 and version 2 for a lot of people? Marketing, maybe a breaking change, but that's a business decision in a lot of cases. I'm a big fan of things like canary deployments, using feature flags to just turn them on and off. So if we push out some code, we push out some things to an infrastructure, and we slowly start turning it on for users. If we run into problems at scale, we can just turn that flag back off, and we don't have to push more bits. We don't have to have, all sorts of crazy headaches of taking things up and down. It's really like a setting in a database or in something like an Azure App Config or Launch Darkly. And we can continuously monitor what happens. Azure DevOps does this. Like, they use feature flags to turn on and off features. Another one you'll see a lot is blue-green deployments. So with canary deployments, you can just deploy stuff on your, one set of hardware. With blue-green, a lot of times you're going to see people have two full sets of their infrastructure, and they're going to have the hot one and the blue and the green. And they'll deploy and switch. You could do this with app services with swapping slots. You'll do this with Kubernetes and a lot of containerized workloads. You'll do blue-green deployments. It'll spin up things and do the traffic. And you can keep both running for a while, so you can instantly flip back. But you can also do it to gradually shut down the old stuff once you're at a good place. Anybody using blue-green? Yeah, a couple of hands. Yeah. Now we talk a little bit about DevOps. So this one's near and dear to my heart. Like I said, I help organize DevOps Days Tampa. Patrick Dubois and Andrew Schaefer, they helped coin some of this. There's a lot of focus on cultural shifts and on automation and feedback loops. You'll see the infinity symbol a lot with the segments around building and coding and testing. And I love this definition, though, by Donovan Brown. DevOps is a union of people, process, and products to enable continuous delivery of value to end users. So when, a lot of times when we're talking to people, they don't care that you release some features to QA. They don't care that you've pushed some stuff into dev. What's in prod and how is it helping the user? Are they getting the features they want to use? So there's a lot of push for culture change with DevOps. One of my favorite books is The Phoenix Project, and it's like going back into lean methodology, but you'll hear things like collaboration over silos, that blameless culture and psychological safety. You'll hear empowerment and ownership and continuous learning. Again, a lot of the techniques we talked about in SRE apply to DevOps, but many of the formal concepts of like error budgets and SLOs, you might not see as much in DevOps. A lot of times if you're looking at a DevOps role, it's going to be around CI/CD and infrastructure as code and kind of cross into the operations architecture aspect. You will see stuff around boards and reporting and like work tracking and stuff, but I've seen it shift more towards like CI/CD over the years. A lot of times the DevOps people will help support and set up processes for like Agile and Scrum and Kanban and pair programming. But there's a lot less emphasis on coding. Every time I've been in DevOps, it's more automation and it's more pipeline work. A lot of feedback loops on monitoring and observability, enabling that, not in the code base, but in the infrastructure level, like setting up the monitoring resources, parsing logs, and helping build an understanding of what's happening with systems. The collaborative stuff, that is where I usually help people a lot. Like usually when people are starting to make this transition, companies are trying to make this transition, it's starting to try to bring those groups together. Even though SRE is a very formal thing and it's very tied to development, I open the door more with DevOps than anything because I think you've got these two walls and it starts getting people to talk about, well, how are you building and deploying the software and how are you monitoring things, and let's have a conversation and let's start moving together. Is this what any of you guys are saying in the field?
So how often have you seen, I know the companies do want to break down the silos, break down the walls between dev and ops, and what I've seen end up happening is another small invisible wall comes up.
There's a new one. There's a new wall in the middle called DevOps.
So,
Yep.
that has been counterproductive.
Yes. That's why I kind of asked about that earlier, because when you have a dedicated DevOps team, it's just a different silo. So that's why I bring up team topologies and how teams actually work. And this is where I think that a lot of times having a DevOps team and a DevOps label and a DevOps thing maybe isn't always the best route. This is a cool book. I highly recommend it to you guys. This actually talks about team structure and how teams are built. And so they actually kind of have done research and analysis and determined 4 key team patterns. Like you have stream-aligned teams, which are like feature teams that are building and releasing stuff. You've got enabling teams that help other teams learn and then they kind of go away. So, maybe there'll be an enabling team for GitHub Actions and they'll go embed themselves and help all the other teams learn GitHub Actions and then they'll go away. Like it's not that they're a dedicated silo. You'll have a dedicated subsystem team, maybe something like a payment or very high order math that only they know. And you don't want everyone to have to go get a degree in statistics, but like these guys can do it and then done. And then maybe there's platform teams. So you can see this shift from SRE to team topologies. And so they kind of break down like, hey, we've got these different teams, and they actually look at how do teams collaborate? How do they talk? How do they interact? Instead of this DevOps silo, it's like, no, really, how do we have our architecture team or security team make a cross-functional group that works together? So we've got someone who could do infra and security and coding and monitoring, all working together, and then they just need to tap into some other group for specialized software or specialized engagements. Do you do X as a service, like providing services to other teams? Do you facilitate just to help them? So this way of thinking like really can change organizational structure. And I see this more with DevOps, these conversations, than I do with SRE. But I feel there's this evolution of, we have a dev person that starts doing the infrastructure thing, and we start having these DevOps teams, and it builds different silos, and let's just break them all down. And then you notice there's a platform team there. And that kind of leads into some platform engineering as well. Who's familiar with Conway's Law? Oh man, you guys gotta learn some software engineering laws. So this was coined by a guy back in the Intel days. He's like, if you have a three compiler team, so people building compilers, you have 3 teams building it or 3 business users building it, it's gonna be a 3-pass compiler. Teams build software based on their architecture. So if you look at a software architecture, you can probably infer the organization structure from that. It's really, really interesting. A lot of times when we start doing DevOps and cloud native work, even platform, you're gonna see people talk about doing a reverse Conway maneuver. And that is designing and architecting software to reflect the team architecture that you want. Changing your organization to align with the software architecture you're building, which is really cool because you can kind of design the collaboration models and layout you want and try to get the teams to reorient themselves into that way. It's really cool stuff. So reverse Conway maneuver. DevOps, you're gonna hear a lot about shift left. Who shifts left? Who shifts right? Who doesn't shift? Okay, so that shift left is just let's do more testing at the beginning, let's do more security at the beginning. Who does the security at the end? Who hates it? Yeah, don't do that. Plan it from the beginning, how you architect, how you authenticate, how you secure things. Like I said, we do a lot of CI/CD. So just like those building and automation and deployment toil tasks we talked about in SRE, we do a lot of this in DevOps. Too much a lot of times, I think, because that seems to be the main focus a lot of times, but it's a thing. CI, as in continuous integration, usually the building tasks, the testing tasks, the acceptance test, and then CD, the deployment. Going back to that blue-green, canary, infrastructure, we want faster releases. We want consistent releases. We want push-button rollback and push-button deploy. We want to be able to know instantly if I've checked in code that has a vulnerable package or checked in a password. I want that stuff right away. I want to know. I don't want it floating out there. Infrastructure as code. Who does Bicep, Terraform, ARM templates, Pulumi, Cloud? Yeah. I barely touch the portal anymore for building architectures. Like I want it repeatable. I want to be able to check it in. I want to be able to scan it with a tool like Trivi or Terrascan and know, oh, I left my HTTP port open. Oh, I didn't secure that endpoint. We can scan that stuff before we ever even deploy it. Make it secure before we even deploy it. I use this all the time, but this also helps you with that BCDR and that reliability. Why? Well, I can just make a new stage and give it a different variable, and now I have a dev, I have a QA, I have a new west, a new east, because I've codified what our architecture is. Yeah, I'm a big fan of testing that. You can use Pester to do a lot of testing. I actually have a sample in one of my Bicep ones where I spin up infrastructure and I validate like this is HTTPS, not HTTP. That's where acceptance tests come in as well. If you want to do acceptance testing, like the application runs, the application can talk to the database and caching, but you can do it with things like Pester. You can do it with things like Trivi and Terrascan and Chekhov. And, yeah.
Do you need to have a developer background to do that?
Not always. It depends upon what you're trying to do. So there's always a spectrum of capabilities. But good question. When I do DevOps with customers, I talk about configuration management a lot. And you don't have to be a developer to know about configuration management, but you do need to understand, hey, between dev and QA, what changes? Your database connection string, cool. Where are you storing that? Are you doing it securely? Are you using like something like a key vault? Are you using like managed identities? How are you authenticating? What's the endpoint? Like, oh, you have a front end and a back end. Where do you put the URL? Is it checked in? Don't check that in. Why are you checking that in? Don't do that. I've started a number of companies. Day one, I get access to source code. I pull it down. there's prod database connection strings in the code base. Like, you don't know me. I have access to your prod database. Why are you doing this? So understanding how configuration is managed, understanding how secrets are managed, I think this is a big part of stuff. A lot of times we'll deploy multiple environments and transform that configuration over and over again. And using something like a key vault, using something like a configuration manager, we can actually version control, and we can know when the connection strings change. We can see who can access it, and we can know, like, hey, our certificate's gonna expire, we need to go renew it. We can roll things back, and we can protect our secrets and purge protect them so they can't just be deleted. So leveraging these tooling is part of, like, DevOps and SRE. This is part of platform engineering. And it does tie into DevSecOps. You know, this is part of that obsession with everything ops. Like, I have a talk on slide ops, like how I make my slides. Like, but this is just part of that shift left movement. Like, how do we put security into every phase? Scanning our infrastructure, scanning our code, monitoring our deployed resources for, you know, configuration, proactive security, looking at vulnerabilities, using things like Dependabot and GitHub, continuously doing checks and validations, and making sure everybody is responsible. Like, it's not a security team thing. Everybody needs to be aware that it's important, which means you need to be, you know, very targeted in what you're saying. You don't want just the noise. Who's been inundated with security noise? Yeah, it needs to be specific and actionable. I could tell you a million stories about breaches and misconfigurations and the losses. You've talked about bonuses being tied to things. Using the tooling and automation, it helps us. We can't all be experts in everything. And if you look at a code pull request or a script and someone says, look at this, if it's one line, they might have 20 things to point out about your capitalization or your spelling. You give them a 500-line file and they go, yeah, it looks good. You totally hard-coded in the password and you send it up to HTTP. It's easy to miss this stuff. Computers are good at this. Use the tooling, use the scanning. We have stuff, you know, like even Sneak, there's an OWASP dependency check. There's all sorts of things that scan your infrastructure. There's stuff to scan your code. Use the tooling. It's better than you with a lot of this stuff. And ask ChatGPT even now, or Copilot. Like, you can go, hey, are there some security stuff? It's not perfect, but it's probably better than you just going, yeah, it'll be fine. Every little bit helps. On both SRE, DevOps, and platform, you're gonna hear a lot about microservices. We want containers, we want microservices. This is a topic that comes up, you know? It gets away from that, works on my machine. You know, you're gonna see Linux in a lot of places. You're gonna see people moving away from Windows onto those Linux containers, Kubernetes, you know, Docker. So that's a topic that you're gonna dive into a lot with platform and with DevOps. It just happens. Like, everybody talks about it at some point, which continues the monitoring conversation. How you monitor Docker and Kubernetes can be very different than how you monitor your Windows server. And now we get to platform. So I talked about how some of the teams happen and how we do some of the application development. Platform engineering really is around, in some cases, abstracting Azure or your on-prem stuff. A lot of times you're going to see people writing tools and scripts and templates to spin up an environment and spin up a code base. It's this blend of software and infrastructure and best practices. So you'll see people coming in and going, I would like an app with a database, please, running in the cloud. And they click a button, and then they're like, here's your repo. It's got pipelines already set up. It's got infrastructure already set up. We've built this template. Go put your code in place. So they're going to have software deployments, usually very consistent with how everything is done. The infrastructure will probably have some predefined, pre-approved template. There'll be some sort of tool or integration or platform. And the idea is you're going to hear developer velocity a lot, or developer experience. This is a term you're going to hear instead of platform engineering quite a bit. So it's trying to build the bedrock of applications. Self-service is a big aspect of this. You hear stories about, hey, I need a pipeline, and I need access to a subscription, and I need a Git repo, and it can take weeks for some organizations to get stuff going. As you start getting, and you got to open the ServiceNow ticket, and then you got to get the approval, and then you have to go to the procurement thing and get the right code. Anyone been stuck in this? Yeah. So the idea is to start shielding developers and people from that underlying complexity in a lot of cases. You're going to see people writing Terraform modules or Kubernetes things where it's like it abstracts a lot of it away, and it's like, here's your app, plug in your name, plug in your stuff. So you have these uniform templates, and you start having consistent patterns all throughout your organization. Another one, who's heard of Gall's Law? And you guys got to read more, come on. So successful complex systems evolve from working simple systems. You can't make an awesome complex thing just out of the box. Complex systems designed from scratch fail. You got to have something working first before you can build something complex. So start small, iterate, don't overcomplicate it. Yagni, you ain't gonna need it. You guys familiar with Yagni? KISS, keep it simple. A lot of times you're gonna be embracing microservices. You're gonna embrace containers. You're gonna see people running lots of clusters and trying to abstract away cloud and everything else into just cloud native. Like we're gonna spin up things on top of Kubernetes. We're gonna spin up things on top of containers. So it's flexible, scalable, and portable. You're gonna be able to dynamically adjust and balance. Again, SRE and platform and DevOps all do this, but it feels like you start seeing this at larger and larger scales with platform engineering. Like I said, developer experience, faster development, more uniformity, baked in resiliency, and they try to future-proof this in a lot of cases. You put in the ticket, you wait, one eternity later. Like this is the idea of getting away from that. I go to a portal or I go to a catalog and I go, I would like one app, please. And it goes, okay, here's your app. Go. It's already been deployed. It's already got monitoring wired in. Go. Remove the security hurdles. Remove the networking setup. So you've automated wiring up the VNets, wiring up the firewall. We've gotten away from the, hey, is it done yet? Oh, I gotta go talk to this guy. Hey, is it done? Oh, I gotta talk to this. That's removed. So self-service, hide the complexity, make things consistent and scalable. And so that's it. SRE and DevOps and platform all have the same core DNA of unifying different groups of people, breaking down silos. So hopefully without creating a new silo. So collaboration, automation, continuous improvement, and ownership. Okay? So everybody does it. You see lots of priorities just in a little different areas, but it all comes together. So thank you guys. Any questions before we wrap up? Questions? Yeah.
So how do you get like security to go ahead and buy into your pipeline to just DevOps in general? Because that's a big issue that we're having in our company.
Policy as code is a thing. They're like, hey, let's help you put policy and permission in our pipelines from the beginning so that you have to approve and review it. Hey, we're building a new application. Can you come join our stand-ups and our discussions, and let's make sure that we're implementing authentication and security correct from the beginning? Most times they'll be like, yes, please, let's. You ask them if they recommend tools to integrate into your pipeline so that you can mitigate a lot of things before it ever gets close to being deployed. Start a dialogue. Break down the walls yourself. Yes?
Do you have any recommendations for getting started with a culture change? Because large organizations often have problems with that?
Oh yeah, so I usually start people with something like the Phoenix Project. I think it's a nice book. I really like team topologies. There's a lot of stuff from IT Revolution. That's the place that writes a lot of books like that, Project to Product, Phoenix Project, Unicorn Project. They're easy novels to read that get the ideas across. There are a lot of things that you can point at. So the State of DevOps report, Microsoft has a site, Developer Velocity. There's a Developer Velocity assessment you can take that actually you can ask questions and it'll point you right to the recommendations of things to do. Those are all good resources, but a lot of times when I was asked to be brought in and help set up cloud centers of excellence and do these DevOps transformations, it was either a C-suite on a plane that read an article and was like, let's do it, and nobody really bought it, and like below him, or it was you're working with engineers and you enable them to choose how they want to work. They want to work cross-team. They want to bake in the automation into their stuff. Like, we've prioritized, I want a pipeline. It's gonna save this guy, or this person, 10 hours a week. So by automating this, we've saved that for the rest of the project. Hey, we wanna get the security approval in place because we're gonna deal with PII and we don't wanna risk the company. Like, bottoms up. Just, like I said, break down the silos yourself. You had a question.
Yeah, so maybe advice on kind of legacy monitoring. We care about thresholds. Threshold, you could have a 90% CPU or 100% RAM usage. Doesn't matter anything at all if like the service that whatever that is providing isn't really impacted.
So with ASP.NET 2, like for .NET applications, for instance, ASP.NET 2.2, they added health dashboards and health monitoring, like baked into the platform. If you're on Azure, Azure Monitor can give you a lot of insights through like auto instrumentation. Like, you can get app insights on an application without actually making any code changes. And you can install those agents on on-prem IIS and on-prem servers to get some of those monitoring insights. Shipping all your logs to log analytics and using Azure Monitor, for instance, you can, or if you're doing a Datadog or Splunk or something, just trying to correlate like time frames of here's our CPU, and here's our traffic on the website, and here's our orders going out, and let's put them in the same timeline and we can watch CPU go up, order go down. That equal money.
I would say like the legacy sort of mindsets there.
Yeah.
With something like Big Panda or some type of like machine learning, just.
I mean, you can.
Give me the green or red dot.
Yeah, that's actually something I would, health modeling, let's see here. This actually just went up, last year, health modeling in like critical workloads and like how to do a health model of application and layered health. Like, there's good documentation out there. This is like using queries and like, hey, let's make a graph of service A breaks service B. Like, do you know what those things mean? So if you look it up, and then there's lots of architectures that we provide around like mission critical workloads, enterprise reliable web apps, stuff like that. And we're a couple minutes over. I'm sorry about that. I can stick around for questions, but any other questions from anybody? All right, well, thank you guys for coming. I really appreciate it. I'm gonna get a selfie real quick, if you don't mind. Is that okay? You guys cool with selfie? Let's do this. Thank you guys. I appreciate it.